describe a combined variation. This is a combination of all the variation types that we had learned, namely direct, inverse, and joint. Z varies jointly as y and w, and inversely as the square of x. As you see, we have jointly. So we will write the equation. Z varies jointly, meaning we will multiply this with our constant of variation, y, w, and inversely as the square of x squared. So this is z. Okay? Then, let's have the solution for formula for the constant of variation. We derive z equals kyw over x squared. We multiply this. So we have x squared z is equal to kyw. Then we are going to eliminate the variables beside k. To find k, we multiply 1 over these two variables, yw, on both sides of the equation. Then we cancel is equal to 1, k times 1. And then on the left side, we have 1 times x squared z is x squared z over yw. So this will be our formula in finding k. Let's just rewrite. K is equal to x squared z over yw. After finding that, now we can continue solving for what is asked. Identify the variables. We have z is equal to the value, 360. Y is equal to 24. W is equal to 20. X is equal to 4. After identifying all these values, we can substitute to find the value of k. X is 4 squared. Careful with substitution. Z is 360 over y, 24 times w is 20. Okay. So, let us simplify this. We have 4 squared is equal to 16 times 360 over 24 times 20. We may multiply everything together, but it's easier if we will use simplifying or cancellation to make the given numbers smaller. Okay, so 360 divided by 20 is 18. Then next we have 16 and 24 are both divisible by 4. 16 divided by 4 is 4. 24 divided by 4 is 6. And then finally, 6 and 18 are 18 can be divided by 6. So this is 1 and this will be 3. Now, what do we have for k? In the numerator, we have 4 times 3 is 12. And in the denominator, we have 1. So the answer is k is equal to 12. After finding K, now we can rewrite our formula by substituting the value of our K. So K is 12. Here, our formula will be Z is equal to 12YW over X squared. Again, this will be our formula for the given problem. If P varies directly as the square of P and inversely as the square root of R. Okay, let's write it. So we have P varies directly. So as the square of Q. So we have Q squared. And inversely as the square root of R. So the square root of R. So our equation will look like this. And then we need to find the equation for finding the value of the constant before we can proceed to finding the value of what is asked. So let us derive again. That's P is equal to KQ squared over the square root of R. We cross multiply. Then we'll have P square root of R is equal to KQ squared. And then we will simplify by removing the Q squared beside K by multiplying 1 over Q squared on both sides of the equation, and that would be cancelled. That's K now is equal to P square root of R over Q squared. So we will just rewrite it. Our formula for constant of variation is P square root of R over Q squared. Okay, then let us solve for K by taking the variables and its values. So we have P is equal to 60, Q is equal to 6, R is equal to 81. Let's substitute. K is equal to 60 times the square root of 81 over Q squared is 6 squared. Then let's simplify. That's K is equal to 60. Square root of 81 is 9. And then 6 squared is 36. Now let us simplify. Let's use cancellation. So 9 and 36 are both divisible by 9, 1, and then 4. Next, 4 and 60 are still divisible with each other. 60 is divisible by 4. So 60 divided by 4 is, this is 1 and this is 15. So in the numerator, we have K equals 15 times 1. 15 in the denominator is 1. That's also 15. K is equal to 15. Now let's change the equation. That would be P is equal to 15 Q squared over the square root of R. Okay, we're going to look for P when Q is equal to 8 and R is equal to 144. Now we substitute. we have P is equals to 15 times 8 squared. Let's not forget the squared. Over square root of 144. Then we simplify. So that would be P is equal to 15 times 8 squared is 64 over the square root of 144 is 12. Then we simplify. We may use cancellation. Let's use 15 and 12. Both are divisible by 3. This is 4 and this is 5. Now, 64 and 4. 64 divided by 4. This is 1 in the denominator and 16 in the numerator. So, P now is equal to 5 times 16, which is easier to multiply than having a big number, 15 times 64. And then in the denominator, we have 1 left. So the value of our P is 80. For our word problem, we have the number of T minutes needed to solve an exercise set of a variation problem N varies directly as the number of problems and inversely as the number of people working on the solutions. It takes 4 people 30 minutes to solve 18 problems. How many minutes will it take 6 people to solve 42 problems? Let's have first the equation for that. So it says T is needed to be solved varies directly. So we have K, N with a number of problems and inversely with the number of people. So that's P. Of course, step 1, we need to solve or we need to derive the formula for K. So that's T is equal to Kn over P. This will be Tp is equal to Kn multiply both sides by 1 over n. K is equal to Tp over n. Or we can rewrite K is equal to Tp over n. This is our formula for finding the value of our constant of variation. And then we will substitute each given variables and its value. So T is given as 36. We have N is equal to 18 and P is equal to 4. Now let us solve for the value of K by substituting each value to our equation. K is equal to 36 times 4 over 18. Then we simplify. I'll use cancellation. 18 and 36. This is 1 and 2. K now is 2 times 4 is equal to 8. After finding K, now we can change the equation. It is now T is equal to 8n over P. How many minutes? So, we're looking for the time given people is equal to 6 and the number of problem is equal to 42. Okay, Let us solve. Substitute. We have to find T8, the constant of variation, times 42 divided by 6. Now, what is this? So, we can cancel 42 and 6. This is 1/7. Now, is equal to 56. So, the time is 56 minutes. Final answer. Answer is 56 minutes to solve 42 problems for 6 people.